ever hear these before? Did you do them with Miss Davis last year, permutation combination? I mean, in 7th grade, it used to be a big thing, in 8th grade maybe, but it's not that big and it should be. I know I do it in stats with my stat people. All right, so the first thing is this idea of what's called a fundamental counting principle. Use the fundamental counting principle to determine the number of items in the sample space for the following event. So let's say you go to your closet and your mom's like, go ahead, pick an outfit out for school. And in your closet, you've got like 10 shirts, you know, 5 pairs of pants and 20 shoes, you know, and you're like, well, how many different combinations of one outfit could I make? Do you know what you're supposed to do with those numbers? Do you remember by any chance? You just multiply. It's all you do. And that'll tell you how many different combinations of outfits you can, of one outfit you can make. So here's some examples of the fundamental counting principle. Selecting a 4-digit PIN number. First of all, how many digits is in our number system? Digits. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the number 0. 10 is not a digit. 10 is a 2-digit number, okay? So there are 10 digits. So if I said, now here's the way I do it. I make boxes or I make little underline. It really depends on what I'm doing. What is your choice? How many choices do you have for the first number in this password? How many choices do you have? 10. How many choices do you have here? How about here? And how about here? So if you multiply them together, because that's what the fundamental counting principle says, you would have 10,000 different combinations of numbers that you can do for a 4-digit PIN. Cool. A lot of combinations. Well, what if I made it different now? What if I said, select a 4-digit PIN number if the first digit cannot be 0? Okay, so here's my 4 digits again. The first can't be 0, so how many choices do I have? 9. Can the second number be 0? So how many is that? 10. How many here? How many here? Times them all together? 9,000 choices when I start getting restrictive. Selecting a 4-digit PIN number if repetition of numbers is not allowed. Oh, so 1, 2, 3, 4. I'm not allowed to repeat. So that means my first choice could be 10, but then what happens here? What happens getting that password? That's why they do this now. It's crazy to me because it used to be like, oh, 4-digit PIN, that's good enough. Who's going to go through 10,000? A computer can run through it real quick. So interesting. All right, selecting 3 officers, president, vice president, and secretary from a club of 9. So I'm going to pick 3 officers. So I'm going to have 3 spots. I've got 9 people in my club. So how many choices do I have to be president? 9. How many choices do I have for vice president? Do I still have the 9? Why 8? Exactly. And how many here?
7.
So 9 times 8 times 7, whatever that happens to be. 3A, generating a lineup for 9 players on a ball team. Okay, so I have, for those who play baseball, I would have 9 players on the ball team. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I want to generate a lineup. So my player number 1, I have 9 choices, right? But player number 2 would be now how many choices?
8.
And then how many?
7.
And all the way down, would you agree? Until I get down to the last choice, I only have 1 guy left. Okay, and I will give you this one. I have it written down, 362,880 different ways to generate a lineup of 9 players. All right, listen to this one. Generating a lineup of 9 players on a ball team if the pitcher bats first and the catcher bats last. So I've got, again, 9 positions, 1, 2, 3, 4, 5, 6, 7, 8, 9. But how many choices do I have for this first guy? 1. It has to be the pitcher. Okay. How many choices do I have for the last guy? 1. So look at that. How many have I used right now? 2 players. So then for the second position, how many choices do I have? See, this is making sense to you, right? 7, and then how many here? 6, 5, 4, 3, 2. By the time I get here, I still only have one choice. You multiply all these together now, and you would get your answer. I think I have 50, 40. Yeah. All right, number 4A, putting 5 books in order on a shelf. Putting 5 books in order on a shelf. Thinking 5 books. Let's do 5 books of the Bible. I don't know, Genesis, Exodus, Leviticus, Numbers, Deuteronomy, all right? And I'm putting them, I have a book separately for each one. So I have 5 different books. 1, 2, 3, 4, 5. How many choices here? How many choices here, though? 4. How many choices here to have books? How many here? 1. Multiply that out. That's 120 different ways. 120 different ways to arrange those books on a shelf. And then 4B, arranging the letters in the word prime. Okay, so prime has 5 letters. 1, 2, 3, 4, 5. How many different letters could I put for this first position? How many here? How many here? 2, 1. Okay, now, what you didn't notice within this fundamental counting principle is you had these 2 different things called a permutation and a combination of these fundamental choices. And let me tell you the difference between the 2, and then we'll talk about these symbols right here. Permutation is when order matters. Order matters in a lineup of batters. Order matters in an arrangement. They use the word arrange this. Order matters in president, vice president, secretary. Order matters there. Because me picking Ali as president and Ada as vice president and Dylan would be one way, but then making Ada the president and Ali the vice president and Dylan would be another way, okay? So that's where an order matters. So order matters with these things. Now, do you see this symbol here with the exclamation point? This is called in mathematics n factorial. And n factorial means that you would take the number, like if I write 7 factorial, and I would go 7 times 6 times 5 times 4 times 3 times 2 times 1. I'd go all the way down. So did you not see that up here when we generated a lineup of 9 players? We went from 9 all the way down to 1. Would you agree? So that was actually another way to write this is n factorial. Okay, cool thing, your calculator has the factorial button on it. I'll show you that in a minute. I want to go over this permutation though. Okay, so again, order matters. Permutation symbol is NPR. This number in the front always has to be your biggest number, your bigger number, okay? And then R is the smaller of the 2. So I will give you an example here and we'll write this in the correct notation. The Board of Trustees at the Authors College has 9 members. Each year they elect a chairperson, a vice chairperson, and a secretary. How many different slates of candidates are possible? Okay. So out of those 9, they're choosing how many positions? 3. So the way you would write it would be 9P3 because order matters here since you're doing chairperson, vice chairperson, secretary. The formula, I just want to show you how to do the formula, then I'm going to let you cheat on the calculator. You're welcome. The formula says to now write n factorial. So what number would come up here? 9 factorial. The bottom says now do n minus r factorial. What is n minus r? 9 minus 3, which is equivalent to 6 factorial. So now watch what happens. 9 factorial is actually 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, I have 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. What are you allowed to do from top to bottom when you're multiplying things? There's your answer. 9 times 8 times 7. And we had already done that. Now, you want me to show you the cheat way?
Yes, ma'am.
Darn it. I was hoping you'd be like, no, Miss Aceta, I am just kidding. Okay. Go to your calculator. Go to the word math. Arrow over to the word prob. Do you see that little factorial button there? Better than that, do you see NPR? Okay, if you have the math and then arrow to prob. Go down to NPR. If you have the newer calculators, it kind of makes two empty boxes for you. If you have the old calculators, you would actually have to write 9, then go into math prob, then do 3. But you just put a 9 here, a 3 there, hit enter, 504 is your answer. Boom. Can you handle that tonight? Sure can. Sure can. All right, almost done. Turn it over. So what's the difference between permutation, combination? Okay, permutation order matters. It matters that you're the president, she's the vice president. Okay, that's one order. Then switch them up. Now she's the president. Okay, that's the second order. Combinations, order does not matter. I can't even spell. Order does not matter. So let me give you an example of where order does not matter. If you go to, and I always give this one, this is my favorite one to do. If I go to the pizza store and I say, I would like a large pizza with pepperoni, mushrooms, and onions. And then Ryan goes to the pizza store and he's like, no, no, no. I want it with onions, then pepperoni, then mushrooms. What are they going to make us? Order didn't matter. It didn't matter that Ryan said it one way and I said it another way. It's the same thing. That's called a combination, okay? Order doesn't matter. There is a formula for combination. It's NCR. Did you happen to see it on here? Do I have to go over this then? But again, that N has to be your larger number. Don't put the smaller number here. You'll get it wrong. It has to be the larger number, okay? That's the big number. The N is always your big. So let's calculate. Let's use our calculator to calculate 8, choosing 8 combination 3. So math, prob, NCR, put an 8, put a 3, 56. Wow. Now again, you can follow the formula. And if you take a higher level math, you'll be able to do these formulas. Here's another example. There are 20 people in it. There's 20 problems in a test bank, and the instructor is selecting 5 problems to use on the exam. How many different tests can she make? Does order matter there? No. Okay, so you would say, what number would go here? And what number would go here? 5. Put in your calculator. $15,504. That's how many different ways she can pick a 20 problem test of 5 problems. That's crazy. In a team, 12 football players, 3 captains will be chosen to greet the opposing team. Now, this is where you're like, but Mrs. Seti, you said president, vice president matters. Yeah, but these are just 3 captains. It's not captain 1, captain, co-captain number 2. It's just 3 guys, okay? So it's 12 out of the 12 football players. I'm going to choose 3 captains. Order doesn't matter there, okay? It's not like you are number 1 captain. And then you just put it on your calculator and tell me what you get. Anybody get that one? Oh, by the way, do you know how to do it? Like if you already had the C right here, you can just hit second enter and it repeats that line above it. And then you can just move your arrow and type 12 to 20. It's another just trick ways, baby. Got to get them. Sally is packing to go on a trip. She has 7 dresses. She's going to take 4 of them. How many different ways can she fill her suitcase? Like, who is that? Come on now. No one does